Welcome back to the Deep Dive. We're the show that really tries to cut through the noise and get straight to the insights you need.
Yeah, helping you stay well informed.
Exactly. And if you've ever felt that, data overload, especially something like Excel, which is everywhere, well, you're in the right place today.
Definitely.
Our mission today is simple. Give you a real shortcut, a fast track to understanding the absolute core building blocks of Excel.
We're talking about tools that might seem basic, but honestly, they're the foundation for any real data analysis.
From just quick checks all the way to those big executive dashboards.
Absolutely.
All right, let's unpack this then. We're diving into what we're calling Excel's Foundational 9.
And these aren't like hidden, super advanced functions.
No, not at all. These are the essentials, the things even the most experienced data pros use, like every single day.
They're the primitives, the things you absolutely need to turn raw numbers into something useful, into actual intelligence.
What's fascinating about these, though, is how they seem simple on the surface.
Right. But mastering how to apply them, understanding what they really tell you, that's what takes you from just entering data to actually extracting value from it.
So for this deep dive, we've got a data set. What are we working with?
We're using a pretty rich health and safety data set. It's got 40 records detailing real workplace incidents.
Okay.
Things like severity scores, lost training hours, and crucially, the financial costs tied to each incident.
So a good mix of numbers and context.
Exactly. It's the perfect canvas to show how these foundational functions aren't just about calculation. They inform real vital decisions.
And that's the real magic, isn't it? With these functions, you're not just crunching numbers, you're instantly setting yourself up to build, say, an initial diagnostic dashboard.
Turning that raw incident data into something leadership can actually use.
Right. We've got our 40 records, clean beta, already set up in an Excel table, so it's ready to go. Let's just jump right in.
Let's do it.
First one up, the SEM function. So you've got this health and safety data, all these incidents, different costs. Your exec team comes asking, okay, what's the total cost of all these incidents?
Oh.
They need that bottom line figure, right?
Yeah.
The budgeting, resource allocation.
Precisely. They need that overall impact number. And SUM is your go-to, your absolute first tool for that.
Most people know SUN just add stuff up.
Sure. But for someone working with data seriously, the insight isn't just the total. It's how SUM anchors your financial reporting.
Anchors? How so?
Well, it transforms that list of individual costs into one single quantifiable financial burden that lets you immediately see the absolute impact.
Okay, I see. It's the starting point for maybe zero-based budgeting for safety or comparing different interventions.
Exactly. It gives you that solid number to build from.
And what's great is Excel makes it even easier sometimes. That Alt plus shortcut, love that. It just highlights the range, boom, sum.
Oh yeah, super quick. Or the total row in an Excel table.
Right. If your data's in a table, just toggle that on, click the drop down in the cost column, select sum. Done. No formula typing needed.
It feels like a little bit of magic, but it's just pure efficiency, especially when you need numbers fast.
But the real power, especially for analysis, it's dynamic, isn't it?
That's the crucial part. SUM isn't static. If another incident happens, you add a row to your table
The total updates automatically.
instantly. That live reporting is key. Imagine using that total cost as a benchmark for, say, a safety incentive program.
You need it to be current.
Exactly. It removes manual errors, keeps decisions based on reality, not, last week's numbers. Real-time decision-making.
Okay, so SUM gives us the total picture. But what about the typical picture? What's the average severity or average training hours lost?
Right. Leaders often ask that, don't they? On average, how are our safety inspections doing? Things like that.
Which leads us straight to the average function.
An average gives you that mean value. But here's where a data pro thinks a bit deeper. Average can be really sensitive to outliers.
Good point. One really bad incident could pull the average way up.
Exactly. It might mislead you about the typical situation.
Sure.
So while average range on our inspection scores gives us, say, 83.05.
That's our baseline number.
It is, but you immediately know, okay, I need to look at the distribution too. Does this average truly represent the common score, or is it skewed?
That's critical thinking applied even to a basic function. Love it. And just like SUM, the total row in tables can do average too, right?
Yep, quick drop-down selection puts that key performance indicator right on your dashboard instantly.
So useful for tracking trends then.
Absolutely essential. If our baseline average inspection score is 83.05, and next quarter it jumps to 86.
We know things have improved, on average.
Right, but the deeper insight comes from asking why. Was it better training, new procedures? Average tells you the what happened.
So you can start digging into the why.
Exactly. It lays the groundwork for more detailed analysis, for strategic adjustments. It's fundamental for those dynamic comparative dashboards.
Okay, totals and averages give us a central view. But what about the extremes? The best and worst cases?
Yeah, you need the boundaries to really understand the landscape.
Which brings us to MIN and max. Let's start with minimum, or just MIN. This finds the lowest value.
Yeah.
Right. So if someone asks, what's the least severe incident we recorded, MIN is your tool.
Yep. The formula is just MIN range. Apply that to the severity score column, and you get the minimum score.
And I'm guessing total row option again.
You guessed it! Quick way to find the minimum in a table. But the genius of MIN, I think, isn't just finding the smallest number. It shows you your absolute floor.
Your best case scenario within that data set.
Exactly. In health and safety, knowing that lowest severity score gives vital context. It defines the positive end of your performance spectrum, especially when you pair it with
Its counterpart, maximum or max. If MIN is the floor, max is the ceiling.
precisely. It finds the highest value, like the highest severity score in our data.
Formula is max range, I assume.
You got it. And yes, total row works here too for speed.
So how do MIN and max work together for insights?
Well, connecting them to the bigger picture. They don't just give you a range, like, say, severity scores run from 1 to 9. They define your operational variance.
Operational variance.
Yeah, and potential failure points. The insight comes when you track them. Maybe your MIN cost stays low, but your max incident cost starts spiking upwards.
So the average might not change much, but the worst cases are getting worse.
Exactly. It signals a growing skewness in your risk profile. It tells you, hey, don't just look at the average, investigate these extreme events.
So for our data, if MIN severity is 1 and max is 9, that max of 9 is an immediate red flag.
Right. It screams, at least one very severe incident occurred. Tells you where to focus your attention first.
Okay, moving beyond the values themselves. What about just counting things? How many incidents actually resulted in lost time?
That's where count comes in. It answers a very specific question. How many numeric entries are in this range?
Numeric only.
Numeric only. So take our lost time in days column, if we use count range on that.
Assuming all 40 incidents had lost time, it would return 40.
Correct. But the subtle power here is its selectivity. It ignores blanks. It ignores text.
So if someone accidentally typed none instead of 0.
Count would ignore it. And that's where the aha moment comes for data professionals. You use count for data integrity checks.
Ah, I see. It shows you where you have actual usable numbers, like an instant quality control.
Exactly. Clean, reliable counts of where real quantifiable data exists.
Now, there's also Counta, right? Similar name.
Similar but more inclusive, as the A suggests. Counta counts anything that isn't blank.
Text, numbers, dates, even errors.
Yep. As long as the cell isn't empty, Counta counts it. Count a range.
So when would you use that? Maybe on a column with incident descriptions.
Perfect example. Use Counta on incident descriptions. It tells you how many incidents have some kind of description entered.
Okay, but where's the magic in pairing it with count?
Here it is. Imagine Counta on your incident ID column tells you there are 40 incidents.
Right, we have 40 records.
But then count on your days lost column only gives you 30. That immediately flags 10 incidents where the days lost is either blank or has text. Incomplete data.
Bingo. That discrepancy is your fastest data validation check. It instantly reveals potential holes in your data collection that could seriously skew your analysis, especially on something like productivity loss.
That's really useful. Okay, let's switch gears a bit. Presentation. Raw numbers, especially with loads of decimals, they can look messy, right?
Oh, definitely. Makes reports hard to read, potentially confusing.
So we need to talk about rounding, essential for clarity. Let's start with the main one, round.
The workhorse. Round value, num digit. That's your formula.
And num digits tells it how many decimal places you want.
Exactly. Or use 0 to round to the nearest whole number. The key principle for round is nearest.
Well, like 1719.52 becomes 1720.
Right. But 1719.49 would go down to 1719.
Standard rounding rules we learned in school.
Pretty much. And its value, presentation. Like you said, nobody wants endless decimals on a slide. Round makes data digestible, professional, easy to grasp quickly.
Less visual clutter means better decisions. Absolutely.
Okay, so round goes to the nearest. But sometimes you don't want nearest. Sometimes you need to always go higher, right? Like in budgeting, maybe.
Exactly. You need a conservative estimate. That's where our eighth function, round MUB, is perfect.
Name says it all. It always rounds up.
Always. Doesn't matter if the decimal is 0.1 or 0.9. The formula, round to UP, value, num digits, takes the value and pushes it upwards to the specified number of digits.
So give me an example.
Okay, say you have 1719.01. If you round DUP to 0 decimal places.
It becomes 1720, even though the decimal was tiny.
Precisely. This is crucial for conservative estimates. Financial planning, resource allocation, anywhere you want to err on the side of caution, build in a safety margin, avoids underestimates.
So round for nearest, round EP for always higher. Which brings us to number 9, which isn't really a new function, is it? It's about the choice.
It's the strategic choice between rounding types. Knowing the syntax is one thing. Knowing when to deploy round versus roundab is the real skill.
So just to recap round quickly, if we did round value 0 on that 1719.01.
It would go down to 1719 because 0.01 is closer to 0 than it is to 1.
Right. So the choice matters.
Massively. The critical takeaway is they serve different strategic purposes. Round is great for general reporting, keeping things tidy while staying close to the actual number. But round UP is your tool when you need that buffer, that conservative edge. Think about calculating, say, how many buses you need for a field trip. You get 4.1 buses from your calculation.
You can't order 0.1 of a bus, and rounding down leaves kids behind.
Exactly. Round UP to 5 ensures everyone gets a seat. It gives you control based on whether you need accuracy, conservatism, risk mitigation. It ensures your numbers tell the right story for the decision at hand.
Okay, let's try and unpack all that. We've covered 9 foundational concepts. 7, average, min, max, count, counter, round up P, and crucially, that strategic choice between them.
Yeah, they seem simple individually.
Simple, yes, but honestly, without really getting these, you can't build effective dashboards, you can't generate reliable reports, you can't even really start doing deeper analysis properly.
They are the absolute bedrock, the essential building blocks of data literacy in Excel.
So connecting this back to the listener, hopefully there was an aha moment there that went beyond just learning a formula.
That's the goal. By really grasping these tools, you now have the power, like right now, to calculate total costs, find average scores, spot your best and worst case scenarios,
Validate your data using count and counta.
and present everything professionally using roundup appropriately. You're genuinely transforming raw numbers into actionable insights.
Ready to inform actual decisions, not just sit in a spreadsheet.
Exactly. It's a big leap.
It really is. And hopefully achieve pretty quickly. So next up in our deep dive series, we're tackling something every single real-world dataset needs: data cleaning functions.
Oh, this is a big one.
It is, because, let's be honest, messy data. It's probably the #1 reason Excel reports end up wrong, leading to flawed analysis and, frankly, bad decisions. We'll show you how to fix that.
Absolutely critical. But until then, maybe something for you, the listener, to think about. This raises an important question, I think. How might these seemingly simple building blocks we just covered, when you start combining them strategically, how might they empower you to uncover completely new insights in your own data?
Insights you haven't even thought to look for yet.
Exactly. Patterns, opportunities, risks currently hidden just beneath the surface. How can these basics unlock something new for you?
That is a great thought to chew on. Brilliant. Well, thank you for joining us on this deep dive. We really hope this has armed you with some powerful, yet pretty straightforward tools.
Hope it was useful.
We'll see you very soon for the next one.